In this video, I'm going to show you how to use the prop.test function to perform a right-tailed test to compare two population proportionate successes. To do this, you need to start by having a set of hypotheses. In this particular case, my hypotheses would be that the proportion of successes from a first population is the same as the proportion of successes from a second population, versus the proportion of successes in the first population is, as this says here, greater than the proportion of successes in the second population. What I'd also need is to decide upon a probability of a type 1 error, and that will be my significance level, my alpha here. And so I'm going to use 0.02 for that. And then based upon that, I can set up a rule for rejecting my null hypothesis, which I'll say here is I'm going to reject if my p-value happens to be small enough, smaller than that 0.02. And now to make sure I'm running a valid test, at least in the real world, I'd have to make sure that my sample, or my samples I should say, meet certain conditions. And so it should be that I have a simple random sample from the first population, a simple random sample from the second population. Basically all my sample values are independent of all the others. And then I'd have to check my data to make sure I have at least 10 successes in each sample and at least 10 failures in both samples there. And if we look here in this made-up data I have both of those options satisfied, or both of those assumptions satisfied there. So I can go ahead and perform this test to check to see if I think P1 is greater than P2. So what I need to do is use the prop.test function, and I'd have to enter in my data. Now I have to start by entering in my number of successes. And since I have two populations, when I enter in my number of successes, I have to enter in a vector. And so if I look back up there, I have 59 successes in the first sample, and I have 27 successes in the second sample. Then I need to enter my sample sizes. And since I have two samples, I need to give both sample sizes there. And I had a sample size of 100 in the first population, and I had a sample size of 200 from the second population. Then what I'd need to do for this particular test, got that scrolled off there for you there, is I can skip the little p-value. I only need that for the one-sided test. And I can go up to the alternative here, and I can type in alternative. And then I have to just tell it this is a greater than test. That's coming from the alternative. And that's enough to run my test there. And I can go ahead and just run that. And then if I come down here, I can check that, hey, I'm doing a two-sided test or a two-sample test. Sorry, didn't mean to say two-sided there. I can check to make sure it's reading my data correctly. So 59 and 27 out of 100 and out of 200. And then I just come down and I check to make sure my alternative is correct. And then I can look for this p-value here, and I can ask, is that p-value, is it smaller than that significance level there? Well, if this was real data, that would be the case. So what I'd do with real data is I would decide to reject my null hypothesis. I'd have reason to believe that it was wrong in favor of the alternative there. But that's how you can go about using the prop.test to perform a right-tailed test comparing two population proportions.